We got surface area, volume. Polygon is made a 2D shape made of line segments. Polyhedron is a 3D shape made of polygons. Therefore, it's made of line segments as well, but they're polygons. So it's a 3D version of a polygon. Now, they still have vertices. They still have line segments, which we call edges. So here's vertex. There's edge. And then this is an important one. You'll hear me be saying this a lot. Is face. The face is the polygon. The face is just the polygon. I'll also say if it's not necessarily a polygon, like a curve, like a circle. So that's important. Oh, here's another diagram of that. Just identifying the vertices, the edges, and the faces. Let's keep going. Somebody's not going to spend too much time on. Oh, a solid is. I think I already mentioned that for number 3. A solid is just any 3D shape. Okay, so that's the word I'll be using for a 3D shape. So prism is a type of solid. Now a polyhedron is then a type of solid, more specifically because it's made of polygons. Now this is what I'm saying. Some students can't identify prisms very well, or they can't identify what the base of the prism is. So first of all, a prism, I'm going to jump to here. I like to think of it this way. A prism is any 2D shape, but extended, or I'll say pushed, into 3 dimensions. So it's a triangle along all there, right? Can you say triangles that make that up all along? That's really what a prism is. You should be able to see that same shape all the way along the 3D version of it. So let's look at the pentagon one here. So this is a pentagonal prism. Now it's named by the bases. So this shape is on its base, but it just as easily could have. Here, I could have done this. I could have drawn the pentagonal prism like this. I could have drawn it like that, and then the pentagonal prism would be not on its bases. So base here does not mean bottom. That's very important. Sometimes a big error is students will think base has to mean the bottom. Nope. It means the parallel congruent. So let me go back up to this now. Prism, 2 parallel congruent faces. All the other faces are parallelograms. So like this one, the prism, the pentagonal prism, there was the parallel faces, and they're congruent as well. Therefore, it's a prism, pentagonal prism, named by its base. The rectangular prism, for rectangular prisms, you can choose the top and bottom as the base. So you could choose the top and bottom, you could choose the right and left, or front and back. So sometimes for shapes you can choose. This one only had one choice, top and bottom, that's the base. Okay, over here, this is a good example. This one sometimes students see rectangles on top and bottom. That's true, but they're not congruent. Okay, they're not congruent. Therefore, that's not the name of the shape. Here's the name of the shape because these are parallel and they're congruent. So it's a trapezoidal prism. I spent a little bit more time on that one because prism is the one sometimes students can't get the right name of it. You can't identify. Anything else I can answer about prisms? Sure, it'd be that one. That one's just from the bottom. So a square would just be a box. Yeah, so you can choose the front and back as the base, or the top and bottom as the base, or the left and right. What do you say? Like this one, you chose square, so that would be a square prism. Mm-hmm. But it also, you could have named it by the top and bottom as a rectangular prism. So it's both. It is both. I like square prism. It's a little more exact than that one. I see what you're saying now. Good question. Anything else? So I might go a little bit faster through a couple others now. Pyramid, same thing, named by the base. So we got a pentagonal pyramid, rectangular pyramid, assuming that's rectangle, and triangular pyramid. They all meet at one point though, right? All the sides converge at a single point. You guys know that one. Remember a regular polygon? All sides and angles congruent, so for a pentagon, all the sides. For a quadrilateral, it's a square. Right? Or an equilateral triangle, all the sides and angles are congruent. Well, the same thing occurs for polyhedron, plural polyhedron. Is you can have a regular polyhedron made of polygons that are all congruent. So it's all congruent regular polygons. But there only exist 5 of them actually. Only exactly 5. These are called the Platonic solids. When this was more of a standard, I used to do used to do an activity where we made these with toothpicks and marshmallows. Did you ever do anything like that with making better shapes? Yeah. Well, it's no longer standard, but I do like that. And there's 5 of them. Some of them you're used to. The cube.
They were even colorful marshmallows.
Triangular pyramid, which is also called tetrahedron. What was the first one? Oh, I just covered 2. There's 3 others. My favorite is the dodecahedron. It's made of 12 regular pentagons. I think that one's pretty cool. That one's hard to make. Anyways, I'm not really going to test you on those names or anything, okay? But I just want you to know about them. What do you call this? This was from last year, or maybe the year before. It's on your sheet too, I think. You remember what you call those? You did them, I know. Net.
What's a hedron?
Yes. Remember that? Net. Doing those? Where it depends on what your teacher did. Maybe you started with this and you had to decide what shape you could form. Or perhaps you started with this and then had to draw the net. I'm guessing that's what you had to do, draw the net.
Yeah.
Where does it say net? What?
I have net, I think, on the back side, but yeah, these are nets.
Got it.
It's just it's the pattern that would make that shape if you folded it up. And usually, your teacher probably told you there's different nets that could work.
Yeah.
There was different nets. Now, good thing this is not a standard for our class, so should not be tested on that. I'm not going to test you on that. But I think up here later I have there's a net. I'm just showing you. Cylinder, cone, and sphere. These are listed separately because they're not made of polygons. They're made of curved surfaces. So they're solids, a 3D shape. But cone, sphere, cylinder, just not made of polygons. Now the next 4 together, right versus oblique. So right prism or pyramid or cylinder, perpendicular. So you can see the right angle here. So more or less they're straight up and down. Versus oblique. Oblique, you might want to write this, the word means slanted. So sometimes your teacher will just say slanted. Like you'll do oblique lines next year. Your teacher might say slant lines.
Oh God, that's not an arrow.
Which actually most lines are slanted. The reason I put this here is we're going to talk about volume between a right figure and an oblique figure, assuming they have the same height and base. The volume actually remains constant. We'll talk more about that later. Last 1 or 2 here, hemisphere, half a sphere. And finally, slant height. So for pyramid and cone, we'll need slant height. Now slant height, you got the regular height. Here's a pyramid. That's the regular H height. But we're going to have the slant height as well, which is, we abbreviate L. It's the height from the vertex down to a side, a lateral side. Lateral meaning not top or bottom. It's the side ones, side faces. And so it's just one of the polygons. So it's the height of the triangle. So if I drew this face, it'd be a triangle. That's the height of the triangle. All right, so we'll do that more with pyramids and cones coming up. Any thoughts on the vocab there? I think most of these we'll be using a lot. can't think of too many that would just straight up test question on that, but we'll be using them a lot. Okay, let's get to cross sections and solve the revolution. So this is on the other sheet here. You can put the vocab away. Probably won't need that anymore. So a cross section. I'll read this definition in a minute, but cross section is really just a slice of a solid. So you slice a 3D figure, and then you look at the 2D shape that is formed. All right, another way to say it is you pass a plane through the 3D figure. So they said the intersection of a solid and a plane. They might say cross a plane with a 3D shape, cross a plane with a cone or something. I like to think of just slicing a solid open, a 3D figure. It's the resulting 2D shape. All right, so a cross section is a 2D shape of a 3D shape, 2D cross section. I think I put on there something. This is like, yeah. Has anybody had like a MRI scan?
No.
Or, had an injury, no MRI or anything? Yeah, I have. And what they do with those and some of these other medical tests, like a CT scan or PET scan, they take, like, I don't know how many, if it's hundreds or like 50 or like 1,000, they take tons of these cross sections and then put them together and they end up making a 3D representation. So what they can do with one scan is just get part of it and they can put them all together. It's kind of cool. Well, I said hundreds of them, yeah. So I'm just showing you a nice little application. Cross section. So this first one, this is A on your page. Yeah. It's triangle. So this is a triangular prism. And they sliced it right here, parallel to the, anytime you're slicing actually parallel to the bases of a triangle front and back, it's going to be the same shape. So right here they sliced it, and then if you look at it, it would be a triangle. Here's where I can show you my cone. So if you slice the cone horizontally, assuming it's sitting on its base, then you just look at it either here or here, it's a circle. And that's the cross section. You slice it at an angle, it would be an oval, which we call an ellipse. And that's what a cross section is. So why don't you try B? Oh, try B and C here. It would be. That's actually one of the practice questions. But yeah, you're fine. Yeah, if you slice this vertically, I can't show you, but it would be a triangle.
Where did you get the drawing?
That was the one I got.
What are we supposed to be doing?
You're writing down what you think the cross section is for B and C. That was just in the map before I just got here, so. Okay, so somebody want to help me out with B? Raise your hand. Yeah. Rectangle, yes. So here, I can try and draw this one. So it's a cylinder on its side. There would be a rectangle that's formed there. Also, another good question that comes up with these is, what's the, like, how do I know? Or like, what's the process? Well, A, I would say you could make a sketch. Try and draw it out. That could usually help. But B, that's what they're testing too. When they ask us, like, can you visualize it, or can you make a sketch of it, and then write down what it is? So there's not a lot of process to it. These are really just, can you visualize it, or can you just see it from there? But I would encourage you to make a shape. Draw a sketch. So that was a rectangle. Very nice. What about C? Now, I'm sorry, I should have mentioned here. This is supposed to be assuming it's on its bases. So, sorry, assuming it is on its bases, and we do a horizontal cross section, what's the result? It's a circle. So right here, it would be a circle. And that's actually parallel to the bases, so it would be a circle. All right, I have a nice little website. This is on Canvas. If you want to check this site out, what you can do here is on the left, you can choose whatever shape you want out of these 5: cone, cylinder, pyramid, prism, or double cone. So like here, we were just on cylinder. And then you can do, on the right here, you can change the slice. And here it shows you what the result is. This is the cross section here on the right. So that's the one we just did. Horizontally, there's a circle. If we did, here, I can show you, that's, there. This is B, but B was on its side, but it's still the same thing. It's a rectangle. Let me slice it there. All right, and you can play around with these other ones. I want to show this. There, that was the one you were asking about, right? There you can see a little better. She said, what if we slice the cone vertically? It's a triangle. Fun stuff. Okay, any questions about cross sections? That's pretty much it.
Is there like a specific name for triangles on top of each other? Because you can do the same thing.
Oh, like that. Double, no, I don't think so. Double triangle.
I
Good question. All right, back to, let's do solids of revolution. Not technically the reverse, but it has some reverse characteristics. So cross section is you take a 3D shape, and you slice it, and you get a 2D shape as a result. Triangle, rectangle, circle. Solid of revolution is you actually take a 2D shape, you rotate it around an axis, rotate a 2D shape around an axis, and the result is a 3D shape. And that would be the solid of revolution. A solid formed by revolving. Here's an example. Take a rectangle, and you rotate it around a axis, a vertical kind of axis. I can't do it very well, but spin this, and you can see
Oh no.
I lost it. But you rotate it around here, and it carves out a cylinder. Actually, all rectangles will carve out a cylinder. Oh, and here's just, I was trying to visualize it for you.
Oh.
Flag. So the answer here was a rectangle. I think the solid this one is a rectangle. Let's do A below. Let's do this one together, then I want you to write in the other two. Here's another common one. So rectangle is very common. Triangle is also very common. So the same vertical axis rotating around here. Anybody help me? What shape do you think it's going to be? It's that. Yeah, it's a cone. I do have a website for this. This one's also on Canvas. Okay. So there's my axis. There's my triangle. We rotate it around. I'm not going to go all the way. But it carves out a cone. And yes, all triangles will carve out.
Wait, what happens when you go around the Y?
It will carve out a cone, but there's depending on what axis. Yeah, depending on what axis you go around, will carve out a different shape. So yeah, you want to see if. So they're rotating around this axis. There's a gap. Then you go to this one. It's just hard to show here.
Go.
There. So it's kind of.
It's an inverse cone.
Yeah, I mean, it's like a cylinder, but it has a cone as the gap in the middle there. It depends on what axis you're rotating around, basically. But in general, you have a cone there somehow. You see that one?
Yeah.
Okay, so back to it here. I want you to do B and C. So you can, I think I said draw. You can also just name if you'd rather just, sometimes these are a little harder to draw. You can name or draw for B and C. Take 30 seconds. What'd you get for B? Raise your hand. Shout it out. Anybody? Mitchell? It's a donut. Yeah.
Oh, I thought it would be fun.
I have a slinky that can actually help illustrate this. So imagine I have an axis right here,
Is that a shape?
and I have a circle,
So you call it a shape?
and it's like the cross sections of the circle are going all the way around.
So you call it a donut? That's really annoying.
Yes.
Well, like, what's the real donut?
Donut. It's a mathematical donut. I'm serious. Look it up. Now you're probably thinking of the food donut, right?
Who else? What else?
Which is this.
Which is the same thing.
Yeah, I don't just think of like.
That's food donut.
Maybe
That's-
like maybe like a.
That's how I spell it. Like
No.
But I did spell it.
Well, you can like think about like a real.
I found a donut.
I know you're right. You're right.
Wait, that's how you
Now
spell it.
I know both are used. Both are acceptable. You can say you can spell it either way.
But no one spells it the second one.
But this is technically the mathematical
I've never
donut.
seen it.
Why you don't spell dough? Like they're made
No one
of dough.
spells it that way.
Dough nuts. All right, so Slinky. I like that one. It just really illustrates what is formed there. You can even see the circles all the way around. C.
Cylinder.
Yeah. Well, just a straight cylinder? I don't know.
Okay.
Well, I know. Well, it's a cylinder, but some. What about it? Yeah, there's a hole in the middle. There's a hole in the middle. Somebody earlier said like a pipe, or what did I? Oh, I said a ring.
A cylinder?
A ring pipe.
Okay. Well,
It's like a long
So there's just a gap in the middle. So it carves out a region. It carves out a region around here, but there's a gap right there. So there's nothing in the middle. Okay. One more thing with this to finish up. Any thoughts right now on solids though? Solid revolution?
No.
Again, drawing a sketch is helpful, but part of what they're testing is visualizing it. Okay, last thing I want to do with this is they give you a 3D shape. How was it formed? How could you have formed it with an axis and a 2D shape? So this is kind of going backwards from the solid revolution. So for example, I have a chess piece, pawn. I'm going to draw on that line. That kind of splits it in half. And then what I can do is that's my axis, and I'm just going to take half of it here. This will not be. Okay, that was definitely not great, but imagine I did that perfectly, and then you could rotate this region around, and it would carve out that pawn.
Yo, what was that?
Oh, here.
Looks like
Last one. I have, I'd say kind of a silo. I know it's not on its face.
oh,
Well, you view it, yeah, you view it that side. So it's made of a cylinder and a hemisphere. Okay, so it's two parts here. Now the first one we already said today, if you want to form a cylinder, you need what shape? Rectangle. That was the first one. If you want to form a cylinder, you need a rectangle. I see some symmetry right there. So here's what I'm going to do. I'm going to draw on this, and I can put a rectangle. I'm just drawing a dotted line because I really don't have to draw. I don't really have to draw on that part. I'm just showing you that it's there. So that would carve out the cylinder part of it. What do I need to do for to get this hemisphere here? Semicircle would be like that. Quarter circle. Because then that would, when going around, it would get all of it. Sometimes I've seen this where it's a cylinder, that's bad, but then a cone, and you would draw on a triangle up top. Because that would map out the cone. Okay.